So in this review of the Chapter 13 material, let me start off with just a conceptual introduction to the solubility graph that we saw in some of the Mastering Chemistry homework. And these are the basic definitions you should be familiar with. Let me focus in on saturated versus unsaturated solutions and how it relates to the solubility graph. First off, in a saturated solution, you're actually seeing some kind of solid in the solution, and that can be any degree of cloudiness would indicate the solid. It means that we have exceeded the solubility for that particular solution. Solubility is dependent upon the temperature and the amount of the solute that's in the sample. In this case, water is our solvent here. Unsaturated solution, what means that you're below solubility, means that all the solid has dissolved. Now, how that relates to the solubility graph, well, let's just take an example here. Let's take a potassium chlorate, and let's just talk about this curve first. All this is saying is that, as we increase in temperature of the solution, then the solubility increases for the potassium chlorate. By the time you get to boiling water, the solubility is almost at 60 grams per 100 grams of water. And at ice water, then you're not even dissolving 5 grams of the salt in the 100 grams of water. And we'll do some calculations with this in just a minute. But let's just take a point on the x-axis and imagine that we start traveling up that vertical line. What this is saying is that, well, down here at the x-axis, I have added 0 salt to my water. And again, the amount of water is specifically 100 grams, about 100 milliliters. And then as I'm adding 0 to 10 to 20 grams of the potassium chlorate, all of that is going to dissolve. It's not going to reach its maximum solubility until it reaches about 30 milligrams or so. Okay, so everything below here, right, not just for 70 degrees, but all of the temperatures, right, anything below that line, all of this dissolves. So this represents an unsaturated solution. Once you've touched that line and then above it, then no more solid is going to dissolve. So again, my maximum solubility at 70 degrees is about 30 grams per 100 grams of water. If I add that 31 gram, 32 grams, or any amount above that point, then it's not going to dissolve. The solid is going to be present in solution, and then we would identify that as a saturated solution. And the same can be said for any of the curves on the graph here. Lead to nitrate, right? Anything above in the graph, it's not going to dissolve. It's going to be a saturated solution. Anything below the line for the lead to nitrate is going to be an unsaturated solution. Let's look at a calculation. I just pulled this from the back of the book. I want to do C for this one. And so we're focusing on this case, the potassium chloride. So it's asking me, is this amount going to dissolve? Will the solid completely dissolve in the solution? Now, if this was 100 grams of water, I could use this chart as it is, and I wouldn't have to do any math because that's 100 grams, but I don't have 100 grams. It's asking, well, what about not 100 grams, but what about 70 grams? How do you approach this? Okay, well, there's a few ways. Let's start in on our 82, and I'm just going to say, 82 is a little bit above, a little bit to the right of this line. So let's go up and just sort of mark that on the chart. And then I can see that that point is a little bit above the 50 grams of the potassium chloride in 100 grams of water. And for my calculation, I said that at 82 degrees Celsius, the solubility for potassium chloride was 52 grams of KCl in 100 grams of water. Now what I have to do, I have to basically compare the mass in the problem, the mass here, versus the amount of water in the two problems. Okay, this is where the approach can vary. What I'm going to ask myself is, well, how much, since I know the solubility at 100 grams, well, what's the solubility at 70 grams for that temperature? There's a few different ways to approach this. Let me talk about one, and then let me do a different one, okay? So one classic way of doing this is to say, well, I know my solubility, right? That's just taken from the graph. Sometimes the information is presented in a table, so much easier at that point. And then I say, well, what is my solubility at 70 grams of water? Well, it would look something like this in a proportion. And you can cross multiply and divide to solve for x. This is one way to do this calculation. If you're comfortable with doing it this way, do it this way. If you look back at my Charles Law videos dealing with back in chapter 11, you'll see me discuss this cross multiply and divide technique. So that's one way to do it. Another way to do it is to say, well, I'm curious about 70 grams, how much sample is going to dissolve in 70 grams of water. And then I'm just going to treat this as a conversion factor. For every 100 grams of water, then 52 grams of the solid can go into the solution. Let's think about this in just a strictly dimensional analysis, unit cancellation game, right? I want to know how much of this salt or how much of this solute is going to dissolve in 100 grams of water. I'm going to put the 100 grams of water on the bottom, right? Because I want the grams of water to cancel out. And then on top, I'm going to have grams of my salt. Notice what happens here mathematically. Multiply, divide by, that cancels out. If I do this math, I get 36.4 grams. And that represents the maximum solubility at 82 degrees Celsius, approximately. This graph isn't great. It's good enough for what we're doing here. I still haven't answered the question, okay? How do I now answer the question, right? I have to do the math before I can answer the question. The answer to the question is, well, yes, it will dissolve. What this number is telling me here is that if that's the maximum amount of the potassium chloride that will dissolve in this solution, right, anything below that value, is going to dissolve. Well, 32 grams is less than 36 grams. Therefore, yes, it will all dissolve in solution. So basically, we're looking at we could also call it an unsaturated solution. So this is one of the most common type of question that you would encounter for using the solubility graph and solubility calculations.